Hello and welcome to Aughton Math. In this edition of Aughton Math, we're going to have some fun with absolute value functions. We're going to talk about the lesson, and then in a separate video we'll do some problems. Okay, well, absolute value functions, what do they look like and how are they written? An absolute value function looks like a V. Why does it look like a V? It looks like a V in this case because regardless of the value that we put in for x, remember the absolute value is going to make that value a positive number. So it's just the distance between 2 points on a number line. Sometimes we might have a negative value, or negative x, but we still get out a positive y regardless. So in this case, regardless of what we put in for x, we're going to get out a positive value for y. So I see if I put in 1 for x, I get out 1 for y. If I put in negative 2, I get out 2 for y. So the graph ends up looking, instead of a line that goes this way, it ends up looking like a V. So the parent function, recall, is that super general function that describes the basic behavior of absolute value in this case. And there are parent functions for other graph shapes as well. In this case, the parent function is based off of y is equal to the absolute value of x. Or we can also say the function of x is equal to the absolute value of x. That's our parent function. Okay, so the vertex in this case is going to be the highest or the lowest point in the graph. And we can see that the vertex here is going to be that point 0, 0. So in a parent function, the vertex is at 0, 0. So again, the vertex is the highest or lowest point in the graph. So let's talk about transformations. Now transformations are changes to a graph that change its size, its shape, its position, or its orientation. So I can, if I were to construct an absolute value function, I might have something that looks like this. I've basically retained its size and shape, but the position has changed. Okay, I've shifted it or translated it over to the right and then down. Okay, so my position has changed. Now I can also change the shape, right? I can change the shape. I can rewrite that same graph and I can make it narrower, right? So now I've changed both the position and the shape. I can also, in some cases, change the size, but in this case we're just changing the shape and position. And then I can also change the orientation. Now the absolute value graph can also be upside down, and we'll talk about when it's upside down based on a relative to the parent function. But I'll give you a hint. If for every, in the parent function, if for every input I always get a positive output, what do I need to change on the outside of the absolute value function in order to say that for every input I put in for x, I always get a negative output for y? So I'll leave you with that as we continue our discussion on the absolute value functions. So I can change the size, I can change the shape, I can change the position, and I can change the orientation. Okay. So let's talk about translations. So we talked about transformations and translations. Now we're going to talk about translation. A translation is a transformation which shifts the graph horizontally or vertically, but does not change the orientation or the size of the shape. So in this case, if I wanted to translate the graph as I did for the first transformation, I just shift it to the right. I'm shifting it to the right and I'm shifting it down. I could also shift it to the left and then shift it up. And that's all that I'm doing to the graph. I'm retaining its shape and its orientation, but I'm just shifting or translating the graph. So that's what we're going to talk about right now as we embellish on the parent function for absolute value. Now, I don't want you to be intimidated by, as we go into this, the variables that are part of the equation. Let's just think about what they mean, and over time it'll become much more simple to you. Okay, the parent function equation of an absolute value can be written, as we said, as y is equal to the absolute value of a. But now we're going to add a couple components to it. Actually, I'm sorry, absolute value of x. We're going to add a couple components to it. We're going to add an a value on the outside of the absolute value symbol. We're going to add an h value on the inside, and then to the right we're going to add a k value. Okay? So as I write this graph, I'm going to give you an example. Y is equal to 2 on the outside times the absolute value of x minus 3 plus 2. So let's identify what our h and k values are, and also our a values. Our a value, the a value is going to be 2. Right, so here's our a value. Our h value is going to be 3. Okay, now this is where many students have a difficult time, because what is represented here in the parent function is a negative sign. That means that in this case 3 is on the other side of the negative side, so 3 is my h value. If I had 2 times the absolute value of x plus 3 plus 2, my h value would be negative 3, because I need to account for this negative sign. It's a positive here. So really what it is 2 times the absolute value of x minus 3 plus 2. Okay? So hopefully you understand that. So in this case, in my original case, my h value is going to be 3. I need to rewrite this here. So my original value is going to be 3, and I'll make this a positive 3 here. And now my k value is whatever the k value is. In this case, it's positive 2. So my k value is positive 2. So I have an a value of 2, an h value of 3, positive 3, and a k value of 2. Now, with the h value and the k value, I can identify what the vertex is. The vertex is going to be equal to hk. So in this case, I have my h, it's 3, and my k, 2. My vertex is going to be 3, 2. All right, so the h value represents the horizontal shift in the graph. So I'm shifting it from 0, 0, which was my original vertex, remember, of my parent function. So I go back to my original parent function, my vertex is 0. Right? Now I'm shifting or translating the graph, and I'm shifting it 3, and it's from 0, 0 to 3, 2. So I shift it to the right 3 and then up 2. So if I were to draw a graph, and I want to identify the parent function vertex, I'm sorry, the shifted to translated graph function vertex, it would be at 3, 2. Okay? The 2 value, the a value, represents the degree to which the graph shrinks or expands or reflects. Okay. So if the value of the a value is going to be less than 1, it's going to end up being wider. Absolute value function will end up being wider. If it's greater than 1, the absolute value is greater than 1, it's going to be narrower. And as you go through problems, you'll figure out why this is the case. And if I have a negative sign in front of the a, if I have a negative value for a, it's going to shift the graph upside down. Okay, so let's go through the same problem. Let's go through it step by step. So step 1, use a parent function to identify the vertex h and k. Well, we did that. We said h was 3, k was 2, so my vertex is 3, 2. Then we're going to identify the a value. The a value is 2. Determined from this value, determine if the graph is wider. If the absolute value of a is less than 1, it's wider. If it's greater than 1, we know it's going to be narrower. So in our case, we have a narrower function relative to the parent function. And then if it's positive, the a value is positive, it's going to be upright, so it's going to be like a v. And if it's negative, or negative 2, it would be upside down, right, like a mountain. Okay, so we've got a v or an upside down v. The upside down v is negative a, and the v itself is going to be just a positive value. Step number 3 is sketch a graph of the parent function y is equal to absolute value of x, and then redraw the graph of the given absolute value function based on the information we have just gathered. Okay, so that's what we're going to do. So we're going to sketch that graph first. We sketched the parent function. Here's our parent function. We'll call it pf. And then we shifted the graph to another vertex at 3, 2. And then we made the graph narrower, a little bit narrower, because the a value of 2, absolute value of the a value, is going to be greater than 1. So this graph is shifted to the right up 2, and then we make it a little narrower because the a value is going to be, absolute value of the a value is greater than 1.